we are going to see stack data structure. So what do you mean by stack data structure? It is nothing but a group of elements which is being organized in the form of bottom to top format, where we can able to take in the form of last in first out principle. So the upcoming lecture we are going to explain about what do you mean by stack, what are the operations of stack, how the stack can be implemented. So these are some of the examples of stack data structure. So you can see here a stack of trays, a stack of books, stack of coins. So how it is being organized. So we will be keeping at the first and we will be removing out from the last. Basically, what do you mean by stack? It is nothing but last in first out principles, and also it is a linear list. Why it is last in first out principles, that I am going to show with an example in the upcoming slide. So it is been ordered in the form of a list of elements, ordered list of elements. So in the given diagram shows how each and every elements is being popped out. So now in the stack, the operations like insertion and deletion that can be performed at only one end. Consider an element like 1, 2 and 3. I am going to insert this element. So 1 I am going to insert. The topmost element will be 1. Again I am going to insert 2. So now the updated topmost element will be 2. Again I am going to insert 3. Now the updated element will be 3. Topmost element will be 3. Suppose I want to delete all the elements 3, 2, 1. So again I am going to remove out through like this way. So that the top also will be reduced from exit, that is in the decreasing order. So in this we can say that all the insertion and the deletion that can be done in one end, and whatever elements we are been updating, that we can call that as a top. So these are the list of stack abstract data type. So these are the keywords which we are going to use in our implementation of stack. So basically what do you mean by stack overflow? It is nothing but, suppose we have inserted all the elements in a given stack. Suppose the stack is full and I want to insert the element, means it cannot be done. So it will show us it is overflow. Next, underflow means I have deleted all the elements in the stack. So suppose I want to delete again in an empty stack, we are calling them as a underflow. So these are the operations we are going to perform in the stack implementation. As I have already told you, last in first out principle. So consider the given example. So the first diagram shows it is a empty stack. Suppose I want to push 1. So 1 is being inserted. And again I want to push 2. So 2 is being inserted. Again I want to push 3. 3 is being inserted. So when I want to delete the last element, so here last element here is 3. Okay, so last in value is 3. Suppose I want to delete the element from the stack. So which is the last element here? 3 is the last element. So that will be going out. So first out. The last in element 3 will be going out as first. So this is the principle of last in first out in the stack. Next we are going to see stack using array. So in the stack, we are going to perform the implementation like stack using array and stack using linked list. So now we are going to discuss stack using array. So all the elements in the stack that will be stored in another type of data structure called as array. Suppose this is the stack. All these elements will be stored in this 12, 8, 21, 33, 18, 40. So this memory will be allocated for the storage of elements for the stack in an array. So in this we are going to perform two operations, that is push and pop. So we will see that now. So consider the operation here. So I am going to insert the element as A here. So basically the stack was -1. That is, if the stack does not have any value, the top value will be considered as -1. Now I am going to insert push of A. So now the top value will be updated as 0. Again, again I am going to push B. Now the top will be updated as 1. Again, I'm going to push C. Top is being updated as 2. Again, I'm going to push D. So now the top is 3. Suppose I want to push E means the stack is full. So it will be considered as overflow because the stack size is being mentioned up to this. Only 1, 2, 3, 4. 4 is the stack size is been mentioned. So if I want to insert one more element after the fourth element, it is not been considered and that will be called as the stack overflow. This is an operation of push. Now comes to pop operation. So this is your stack of elements and your topmost element is placing in the D. Suppose I want to perform pop means D will be deleted and as well as top will also be updated in the next element. So this is the process of last in. Last in value will be D and first out value will also be D. So this is the process of last in first out principle. So consider this example. Now you can see the updated top value as 2 because I have deleted the D. Now C is been, so I want to delete C. So what will happen? Top will also be updated as another value, that is 1 and B is the top element. I want to top the element B. So now top value will be updated as 0 and now element only present as A. So suppose I want to top an element. Now the top value will be -1 and stack is empty. If I want to top again, that is if I want to pop again, that is it will delete again the element after the stack is empty, it will be considered as underflow. This is the concept of pop operation. Now we will be seeing how to implement this push and pop operation in a C language.